Hi. So one of my students came up to me and asked me this question, and this is what's called an optimization problem. And I'll read it for you. A rectangular box with a square base and an open top is to be constructed. If the volume of the box needs to be 108 cubic feet, so this is your constraint. Is constrained by the volume, which is 108 cubic feet. What is the minimum surface area? So what are you trying to do here? You're trying to optimize the minimum surface area. So this is the information that you're trying to take derivative of, and you're constrained by the volume, which has to be 108 cubic feet. So I drew it out for you. It says it's an open top with a square base. And as you can see, I try to show an open top right over here. And then so you have 5 surfaces: the front, the back, the left, the right, and the bottom. So this is what you're trying to minimize the surface area. So I'll actually redraw this a little bit for you, or we can do it this way. We have to set variables. So if this is x right here, the length, the width is also x as well, because it says that it's a square base. With a square base. And then let's call this y right there. That's the height. So the volume of a box is equal to length times width times height, which has to go 108 cubic feet. So the length and the width is x squared times y is equal to 108. That's your constraint. And what are you trying to do? You're trying to minimize the surface area, right? So let's write it down. Minimize surface area. Okay. The surface area of this box is equal to the area of the front plus the back plus the left plus the right plus the bottom. So surface area is equal to the front face area plus the back face area plus the left plus the right plus the bottom. The front face area right over here is x times y. The back area right over here is also x times y. And the left and the right as well is x times y. I'm going to add these. So there's 4 of them. The bottom area right over here is x times x, or x squared. So the surface area is equal to 4xy plus x squared. You notice that the surface area is a function of 2 variables, x and y. There's 2 variables on the right-hand side equation. You have to try to get it down to 1 variable, and the only way you can do that is you have to use a constraint right over here. We're going to solve either for x or y, but obviously solving for y would be the easiest for your constraint. Well, how do you solve for y? Isolated, like Ebola. You have to move x squared to the right side by dividing by x squared. So your constraint is y is equal to 108 over x squared. And that's what's going to be replaced right over here. So the surface area, I'm just going to call it A for area, is 4 times x times 108 over x squared plus x squared. Simplifying that, one of the x will cancel with that x. You're going to have an x on the denominator. That's going to be 4 times 108 is 432 over x plus x squared. What we're going to do right now, since area is a function of x, I'm going to take the area derivative. Now, 432 over x is the same thing as 432x to the minus 1. So taking the derivative of that, I use the power rule, bring it on down, subtract 1. So it's going to be negative 432 over x squared. X to the minus 2 is x squared divided by x squared, plus the derivative of x squared is 2x, and we set that equal to 0. And the way we're going to solve that out is we're going to take x out bust that fraction. Oh, the reason why we set it equal to 0 is you're always trying to optimize, which is you're going to have a CP value at 0. It's going to be either a maximum or a minimum, right, when you take the derivative. You're going to bust that fraction out. We're going to multiply everything here by x squared to the left and to the right. So x squared times negative 432 over x squared will cancel with this x squared. Negative 432 plus 2 times x squared is x cubed is equal to 0. I forgot the 2 right there. 2x times x squared is 2x cubed. We're going to move this over, divided by, move the negative 432 to the right side, divided by 2. And I'm going to finish it up right here over here. It's going to be 2x cubed is equal to 432. I moved it to the right side by adding 432, divided by 2 to the both sides. It's going to be x cubed is equal to 216. And I know the cube root of 216 is, I believe it's 6 cubed. X is equal to x cube root the left side, cube root the right side. I end up with x is equal to cube root of 216 is going to be 6, I believe. So let's make sure on that. 6 cubed is 216, yep. So that's my value for x. So what is the minimum surface area? Since I found the value of x, I'm going to plug it into this constraint issue right over here. So it's going to be 108 times x squared. So 108 divided by 36 is going to be 3. I should have worked this out ahead. I didn't actually work out anything ahead, sorry. So y value is equal to 108 divided by 36 from this equation right here, which happens to be 3 feet. Now, they want what is the minimum surface area, and here's the surface area. We just plug it into this equation right over here. And hopefully that will satisfy your surface area, minimize the surface area. Equal to 4 times x, which is 6, times 3, plus 6 squared. 12 times 6 is 72, plus 36 is equal to 108. Wow! Happens to be the same surface area as the volume right over there. Cubic feet. Feet squared, excuse me. Surface areas are in square feet. Hopefully this will have helped. Again, let's recap what we just did. They give you the volume, which is your constraint right over here. The volume of a box is length times width times height. You have to label it. You have to draw a picture if you can so that you can see what's going on. If it's got a closed top, then you have to have 2x squared because the surface area at the bottom is x squared plus another x squared. But since it's an open top right over here, that means that we have to use just one of the x squared. The front face is x times y. X times y, that's the surface area. There's 4 of those. 1, 2, 3, 4. And then the x squared is the bottom surface area. And so the total surface area is 4x squared plus 4xy plus x squared. And then you notice that the variable is in 2 different variables for the surface area. It's x and y. So using your constraint right over here, you have to solve for y and plug it back into this equation right over there to get it in terms of one variable. Good luck, and if you have any more questions, let me know.